Welcome to my class. So for today's lecture, we will talk about non-parametric methods using nominal level of hypothesis testing. Okay, so in statistics, we have two methods. The first one we call parametric and non-parametric. So what is this parametric? Parametrics assume that population will follow a normal probability distribution. It means that when you draw a diagram, your diagram will have a bell curve shape. What happens if you violate this assumption? For instance, you have positive or negatively skewed distribution. So in that case, you cannot use parametric method. You have to use non-parametric method. In non-parametric method, we will have no assumption about the shapes of our distribution. So in non-parametric, the shapes of your distribution could be positively skewed or negatively skewed. Okay? In this chapter, we will focus on three things. The first one is population proportion, that specifically discuss on one sample and two sample tests. We will also focus on goodness of fit, that will talk about equals and unequals expected frequency. And the last one, we will talk about contingency table. We will cover all the learning objectives except for learning objective number 5. So please take notes of this information. Test a hypothesis of a population proportion. When we talk about proportion, it is the ratio of the number of success to the number of observation. So number of success is our x and number of observation is our n. Okay, let's look at the examples of population proportion. Historically, GM reports that 70%. So this 70% is our pi. Of leased vehicles are returned with less than 36,000 miles. A recent samples of 200. So this is our sample, which is n, found that 158 had less than 36,000 miles. So this 158 is our x. Okay, the second example, record show this is true 90% of the time. So this 90% is our pi, because normally pi will be in the forms of percentage. A recent samples of 200. So this 200 is our n, and found that they were successful 190 times. So this 190 times is our x. Okay. If you want to test a hypothesis about a population proportion, you have to make sure that the binomial conditions must be fulfilled. The first one, the sample data collected are the result of counting. Second, the outcomes of the experiment must be classified in one or two mutually exclusive classes. For instance, when you toss a coin, your outcome is head or tail. Next, the probability of a success is the same for each trial. Then, the trials are independent to each other. And the last one, both n multiplied with the pi and n multiplied with 1 minus pi must be at least 5 values. And this is the formula to compute the test statistic. You have z equals to p. P is our proportion, which is x over n, minus pi over square root of pi multiplied with 1 minus pi over n. Let's look at the examples of population proportion. A Republican governor of a western state is thinking about running for re-election. Historically, to be re-elected, a Republican needed at least 80% of the vote. So this 80% is our pi. So this governor need at least 80% to be re-elected. Okay, so the governor hired a polling organization to survey the voters. The polling organization will poll 2,000 voters. Use a statistical hypothesis testing procedure to assess the governor's chances of winning for the re-election. Okay, in addition to this information, it says that the survey showed that 1,550 people planned to vote. So 1,550 planned to vote. Okay, now let's start writing our 6 steps of hypothesis testing. Step number 1, we have to state the H0 and H1. What is our H1? H1 is pi smaller than 0.80. So what is this pi? Pi refers to proportion. And why do I use the words smaller? Because if you refer to the question, it says that at least means minimums. Okay, So your H null is just the opposite signs of your H1 and contain the equal sign. Step number 2, we have to select our alpha. In this case, we will use 0.05. Step number 3, we have to compute the test statistic. We will be using Z for proportion. And this yellow box will give us the working for computing the Z. Z equals to P. What is this P? Our proportion, which is X over N. Our X is 1550 over 2000 minus our pi, which is 0.8, over square root of pi, multiply with 1 minus pi over N. And this information will give us the Z value equals to negative 2.80. Okay. The next step, we have to formulate the decision rule. You know that if you want to formulate your decision rule, you have to find the CV. So what is the steps to find the CV? You have to refer to the table and then one tail test. Next, your alpha is 0.05 and then you have to refer to infinity. Why do we have to refer to infinity? Because we are talking about Z distribution, and these steps will give us the value of 1.645. Okay, for your information, the signs of our CV will follow the signs of our H1. Because our H1 is less, so our CV contains the negative sign. Okay, the next one, you have to draw the diagram and make sure that your CV is formed or is mentioned as the rejection region. Okay, so what can you say? You have to say reject H null if Z value is smaller than negative 1.645. Okay, step number 5. You have to make a decision by comparing your CV with the Z statistics. Okay, in this case, our CV is negative 1.645 and our Z value is negative 2.8, which is somewhere here. This is our Z. So what can we decide? We can say reject the H null because the Z value falls under the rejection region. Step number 6, we have to interpret our result and we can say the governor does not have the vote to win because you have rejected the H null, and we can say the proportion is smaller than 0.8. Okay? We can also test whether two samples come from the population with an equal proportions of success. So in the previous slide, we have discussed about one sample test. Now we will be focusing on two sample tests. So let's look at the example. The Vice President of Human Resources wishes to know whether there is a difference in the proportions of hourly employees who miss more than 5 days of work per year at the Atlanta and the Houston plant. So we are comparing two plants, Atlanta and Houston. Second, the company wishes to know if there is a difference between the proportions of men versus women. So here we are comparing men and women. So we are comparing two things in this two sample test about proportion. We have to use two formulas when we want to compute two sample tests of proportion. Okay, the first one we have to compute pool proportion. When we talk about carpool, it means that we combine everyone in one car. When we talk about pool proportion, we combine all the information in one formula. So what is the formula for pool proportion? You have PC or combined proportion equals to x1 plus x2 over n1 plus n2. So x1 is just your observation and n1 is your sample. Then you can just plug in this combined proportion formula into the Z formula. So what is the Z formula for two sample tests of proportion? You have Z equals to P1 minus P2. P is just the proportion, which is x over n over square root of PC or your combined proportion, multiply with 1 minus PC over n1 plus PC multiply with 1 minus PC over n2. This is the examples of two sample tests about proportion. A perfume company recently developed a new fragrance that it plans to market under the name Heavenly. Market studies indicate that Heavenly has very good market potential. The sales department at Manly is interested in whether there is a difference. So difference here is to tell test in the proportion. So we have to use the formula for proportion of working women and stay-at-home women. So here we are comparing two things, working women and stay-at-home women who will purchase heavily. Okay, so let's start writing our hypothesis testing. Step number 1, we have to state the H0 and H1. Our H1 is proportion 1 is not equals to proportion 2. So pi here refers to proportion, and we can say that proportions of working women is different or not equals with the proportions of stay-at-home women. H0 is just the opposite signs of our H1. And step number 2, we have to select our alpha. In this case, we will use 0.05. Step number 3, we have to compute the test statistic. We will be using Z for the case of proportion. And the information to compute the Z will be explained in the next slide. Step number 4, we have to formulate the decision rule. Okay, so how to find your CV? The same steps, you have to refer to your t-table and then two-tailed test. Next, your alpha is 0.05 and degree of freedom equals to infinity, and this will give you the value of 1.96. Okay, so the signs of your CV will always follow the signs of your H1. In this case, our H1 is two-tailed test, so you have plus minus sign for your CV. Okay. Manly Perfume Company samples 100 working women. So this 100 is our N1 and 200 stay-at-home women. So this 200 is our N2. 100 working women reveal that 19 people like the fragrance. This 19 is our X1, and for the 200 stay-at-home women, 62 people like it. So this 62 is our X2. Okay, given all this information, we can compute our proportion 1 and proportion 2 together with the combined proportion. And all these three information can be plugged in into our Z formula and will give us the Z value equals to negative 2.207. Step number 5, we have to make a decision by comparing our CV with the Z statistics. So you have to draw the diagram, right? Okay, so our CV is equals to negative 1.96 and positive 1.96. Our Z value is perhaps somewhere here. Z equals to negative 2.207. So what is your decision? We have to say reject the H0 because Z falls under the rejection region. Step number 6, we have to interpret our result. So we have to say working women and stay-at-home women will purchase heavily at different rates or different proportion. The second part of this chapter will focus on goodness of fit test. We can compare and observe frequency distribution. Observe frequency refers to our sample to an expected frequency distribution. So expected frequency refers to the historical data, and you want to know whether these two things are equals or not equals. So let's look at the example. An insurance company wishes to compare the historical distributions of policy types with a samples of 2000 current policy. So here you are comparing the historical data with your sample data collected. So you want to know whether your sample data collected fit the historical data. Goodness of fit test can be divided into two, equals and unequals expected frequency. For this example, we will talk about the equals expected frequency. Buba's Fish and Pasta is a chain of restaurants. Buba is considering adding steak to the menu. Before doing so, he hires a research firm to conduct a survey to find out what the patron's favorite meal is when eating out. Here are the results of the survey of 120 adults. So you can see the favorite entrees are chicken, fish, meat and pasta, and the frequency is also given here. So this frequency is called as observed frequency. For your information, observed frequency will be given in the question, and observed frequency refers to our sample data collected. Okay, your task is to compute the expected frequency. So you have to provide or create another column to compute your expected frequency. How to compute the expected frequency? You have to read the question. Is it reasonable to conclude that there is no preference among the four entrees? So the keywords is no preference. It means that all the 4 entries are equal. So how to compute it? You have 120 frequency divided with 4 entries, and this will give us the value of 30 for each of the entries. So if you look at the answer for expected frequency, all the entries are the same, which is 30. That's why we call it equals expected frequency. Next is the difference in the number of times each entry is selected due to chance, or should we conclude that the entries are not equally preferred? To answer this question, we have to start writing our 6 steps of hypothesis testing. Step number 1, we have to write our H0 and H1. H1 is there is a difference in the proportions of adults selecting each entries. If you want to write it in statistical form, you can write the observed frequency is not equal with the expected frequency. H0 is just the opposite signs of our H1. We can say there is no difference, or there is an equals in the proportions of adults selecting each entries. Or you can also write observed frequency equals to expected frequency. Step number 2, we have to select the level of significance, which is our alpha, and here we use 0.05. Step number 3, we have to compute our test statistic. We will be using chi-square, and the details to compute this chi-square will be explained in the next slide. Step number 4, we have to formulate the decision rule. So before formulating our decision rule, we have to compute our CV, and CV will have a few steps. The first step is that we have to refer to chi-square table and then look at the degree of freedoms. What is the formula for degree of freedom? K minus 1 here. So what is our K? K is the source of variation. You have 4 entries. So 4 minus 1 will get 3. And then your alpha is 0.05. And these steps will give us the value of 7.815. Okay. Then you can say reject H0 if your chi-square value bigger than 7.815. You have to write, or you have to draw the diagram to show the rejection region. The formula to compute our chi-square is summations of observed frequency minus expected frequency squared over expected frequency. So let's try to apply our formula. So the first observation, we have 32 minus 30, and then we have squared over 30. Plus the second observation, we have 24 minus 30, and then squared over 30, plus all the observation until 29 minus 30, and then squared over 30. Summations of all this information will give us the value of our chi-square equals to 2.200. Next, we have to make a decision. So how to make a decision? We have to compare our CV with the chi-square value. We have to draw a diagram so that it is easy for us to see it. Okay, so here is our rejection region, and the value of our CV is 7.815. So what is the value of our chi-square? Chi-square is perhaps somewhere here, which is 2.2. Our decision is do not reject the H0 because the chi-square is outside the rejection region. Step number 6, we have to interpret our result, and we can say the data do not suggest the preferences among the 4 entries are different. Since chi-square is a new statistics for us, let's look at the characteristics of chi-square. The first one, the value of chi-square will never be negative. Why is that? If you look at the formula, we have observed frequency minus expected frequency and then squared. When you have this squared, so the value will always be positive. There is a family of chi-square distribution. It means that you will have different shapes of chi-square distribution. Third, chi-square distribution is positively skewed. If you look at this diagram, the value of chi-square will start from 0, and then the number will keep continuing until positive infinity. The last one, as the degree of freedom increase, the distributions of your chi-square will approach a normal distribution. And you can also look at the example from the diagram. This is the examples of goodness of fit for unequal expected frequencies. The American Hospital Administration Association's reports. So when you look at this word reports, it refers to the historical data, the number of times senior citizens are admitted to a hospital during a 1-year period. 40% are not admitted, 30% are admitted once, 20% are admitted twice, and 10% are admitted 3 or more times. Then a survey. When we talk about survey, this is our sample, or we can say this is our observed frequency. A survey of 150 residents of Bartow Estates, a community devoted to active seniors located in Central Florida, revealed that 55 residents were not admitted, 50 were admitted once, 32 were admitted twice, and the rest in the survey were admitted 3 or more times. Can we conclude that the survey at Bartow Estate is consistent? So consistent means equal or the same with the information reported by the American Association. Okay, so if you look at this yellow box, you have the number of times the senior citizens were admitted, and you also have the report given by American Association, but the report is given in terms of percentage, and you also have the number of Bartow residents, which is our observed frequency. Okay, now you want to compare whether your observed frequency is consistent or equal with the expected frequency. However, the reports given by American Association is in the percentage form. How can you compare the percent with a number? So you have to change the percent into a number. What should we do? We have to take the value of 150, our total number of residents, multiply with the percent given by the reports in American Association. So you have 40% multiplied with 150, and this will give us the value of 60, and then 30% multiplied with 150 and will give us the value of 45. And you can also do for the remaining number or percentage. Okay, so you will get your expected frequency in the last column. Okay, let's start writing our 6 steps of hypothesis testing. So we have to write the null and alternate hypothesis. Our H1 is there is a difference between the local here refers to the Bartow Estate residents, and national experience. So national refers to the reports given by American Association for Hospital Administration. So why do I use the word difference? Because in the previous slide, the word used is consistent. So consistent means equals or the same. So in H1 it cannot contain the equal sign, and in H1 we always have difference or not equals. So for the H null we can say there is equals or no difference or consistency between the local and national experience for hospital administration. Step number 2, we have to select our alpha. In this case we will use 0.05. Step number 3, we have to compute our test statistic. We will be using chi-square. Okay, so you already learned on how to compute your chi-square, right? And step number 4, we have to formulate your decision rule. Given the steps that I have mentioned in the previous slide, you should know how to find your CV. And in this case, our CV is equals to 7.815. So let me draw a diagram. Okay, so this is your rejection region, which is 7.815. And what is the value of your chi-square? In this case, given the previous formula, you should get your chi-square equals to 1.3723. Okay, given this information, you have to make your decision. What is our decision? Do not reject the H null because our chi-square is outside the rejection region. So step number 6, we have to interpret our result. We can say there is no evidence of a difference between the local and the national experience for hospital administration. You can read the limitations of chi-square by yourself. Okay? Goodness of fit test from a normal population. For your information, this part will not be covered in our syllabus, so you can just ignore this slide. Please ignore its example and working. Ignore this part as well. And this part as well. Please ignore it. Okay? Contingency table can be used when we want to test whether two traits or characteristics are related. In other words, we want to see the relationship between two variables. So you can compute the expected frequency or our FE using this formula, which is row total. When we talk about row is like this, multiply with column total, column is like this, divided with grand total. The degree of freedoms or our DF equals to row minus 1 multiply with column minus 1. So let's look at the examples of contingency table. Ford Motor Company operates with 3 shifts per day. Okay, so the vehicles are classified as to quality level, whether the quality is acceptable or not acceptable. And the shift can be divided into 3. We have day, afternoon and night. So is there a difference in the quality level on the 3 shifts? It means that if let's say we are producing the vehicle during the day, would it be acceptable quality or unacceptable? If let's say we are producing at night time, will it be acceptable or unacceptable? So you want to see the relationship between the shift and the quality of the vehicle produced. Let's look at the examples of contingency table. Rainbow Chemical Incorporation employs hourly and salaried employees. The Vice President of Human Resources surveyed 380 employees about their satisfaction level with the current healthcare benefits program. The employee were then classified according to their pay type, salary or hourly. Is it reasonable to conclude that pay types and level of satisfaction with the healthcare benefits are related? So in this question, you want to know the relationship between pay type and their satisfaction level. Are they related? So if I want to write it in equation, so I can write it this way. Satisfaction is a function of pay type. Okay, so satisfaction can be measured using satisfied, then natural and dissatisfied, while pay type can be measured using salary or hourly. So you want to know whether the pay type will affect the satisfactions of the employee. Okay, if you have this kind of relationship, or if you talk about categorical variable, two categorical variable, pay type is one categorical variable and affect another categorical variable, you should use contingency table method. Okay, now this yellow box is the information or the information that we have collected from our survey. Okay, let's start with our hypothesis testing. The first step, we have to state the H null and H1. What is our H1? There is a relationship because we want to know whether these two variables is related to each other. So there is a relationship between level of satisfaction and pay type. H null is the opposite. There is no relationship between these two variables. Step number 2, we have to select our alpha, which is 0.05. Step number 3, we have to compute the test statistic. We will be using chi-square, and the information to compute the chi-square will be given in the next slide. Okay? Step number 4, we have to formulate the decision rule. Before formulating the decision rule, we have to find our CV. So we have to refer to degree of freedoms. What is the formula of degree of freedoms? You have row minus 1 multiplied with column minus 1. Okay, what is our row? Row is here, salary and hourly. So you have 2 minus 1 multiplied with the column is satisfied, neutral and dissatisfied. So you have 3 minus 1. This will give us the value of 2 and refers to chi-square table, and then alpha is equals to 0.05 and this will give us the value of 5.991. Next, you have to draw a diagram and make sure that you plot your CV as the rejection region. Step number 5, we have to make a decision by comparing our CV with the chi-square value. Okay, So if you still remember, in the previous slide, there is a box of information. That information is called as observed frequency. So you have to know what is observed frequency and expected frequency. Observed frequency will be given in the question. This is what we call the information collected from the survey, while you are expected to compute the expected frequency, and expected frequency will not be given. Okay, so let's look at this table under satisfied. F0 is your observed frequency and it is given in the question, and you are expected to compute FE, or expected frequency. So let's see how to compute the first expected frequency. What is the formula? FE equals to row total multiplied with column total divided with grand total. So row is here. So the total is 55, and then you have to multiply with column total. Column is here, so the total is 170 over the grand total. Grand total is this one, 380. Okay, so by having all this information, you should get the value of the first expected frequency equals to 24.61. Okay, try to compute the second one, 145.39. The formula is row total, which is 325 multiplied with the column total, which is what? Where is the column total? We have 170 over the grand total 380, and this will give us the value of 145.39. Okay, the next one, you have to compute all the expected frequency for all the observed frequency, and that's why you have to make another column. Okay, then after computing all this expected frequency, you can compute your chi-square value. Okay, what is the formula to compute your chi-square? Summations of observed frequency minus expected frequency squared over expected frequency. So you can start with the first observation, which is 30 minus 24.61 squared over 24.61. And then you can plus the second observation until the last observation. And this information, all working, will give you the value of your chi-square equals to 2.506. Okay, now we have to make a decision, right? So what is our CV? CV is equals to 5.99, and our chi-square is somewhere here, 2.506. So what can we decide? What is our decision? We can say do not reject the hash null because chi-square value is outside the rejection region. Okay, step number 6, we have to interpret our result. What can we say? We can say the sample data do not provide evidence, or we fail to show that the pair types and the satisfaction level is related to each other. Okay.